In this lesson, we will learn how to factor trinomials. So let's make the distinction between the different types of trinomials we will see in this video. Now, the first one is when a is equal to 1. So that means that the coefficient of x squared is going to be 1. So let's see how we can factor something like this. Now, when a is 1, you can think of this as a mental math problem if you're good with numbers. So it's a mental math problem. Once you figure out two distinct numbers, there you go. Your factoring is ready. You don't have to do any extra steps. So how can we figure out these two numbers? We always look at c, which is in this case the negative 21. Now, we always multiply the a times the c to figure out what that number is, the negative 21. But since a in this case is 1, and 1 times any number is itself, we can just disregard the a in this case and just look at the c. So I need two numbers that would multiply to give me c, which is in this case negative 21, and I need two numbers that would add to give me b, which in this case is negative 20. And they have to be the same numbers. Like, for example, if I think of two numbers that multiply to give me negative 21, I have to use those same numbers and they should add to give me negative 20. Okay, so let's review. What numbers am I looking for? I want something that will multiply to give me AC. But since A is 1 in this case, so I want two numbers that would multiply to give me C, so put a dot on top of the negative 21. And I need those two numbers to also add to give me b, so put a plus on top of the negative 20. So what are those numbers? What can you multiply to give you negative 21? Let's put negative 21 on the side and let's think of all the numbers that would multiply to give me negative 21. And these numbers have to add to give me negative 20. So let's think. I know that 3 times 7 is 21, but I want one of them to be a negative. So negative 3 times 7 is negative 21, but let's add them to see if that would give me negative 20. It doesn't, so then that is not the number because negative 3 plus 7 is a 4. What else multiplies to give me 21? 21 if I multiplied by itself. So 21 times 1, that would give me 21. So I want one of them to be negative. Let me put the 1 to be negative. So 21 times negative 1, that's a negative 21, correct. Now if I add those though, I get plus 20, and I want negative 20. So what I do is I just switch the signs. That means I don't want 21 and negative 1. I want negative 21 and 1. So these are the two numbers. So the two numbers are negative 21 and 1. Negative 21 and 1. So let's double check. If I multiply negative 21 times 1, that gives me negative 21, check. Negative 21 plus 1, if I add those, that gives me negative 20, check. So then these are my two numbers. Then I'm done factoring. I just put an x in front of each one of them, each number, and that would be my factor. So the first factor is x minus 21, and my second factor is x, and the 1 is a positive, so plus 1. And there you go, I just factored. Now this tree, you don't have to do it if you directly know what the two numbers are, but if you are stuck, this table will help you write down all the factors, see them, so you can add those factors and see which one do you want. So let's review. It's always a times c, but since a is 1 over here, so I need two numbers that multiply to give me c and add to give me b. If I can't think about them, I create a tree to help me figure out what the factors are. Once I figure out the numbers, I'm done. Then my first factor is x minus 21, and my second factor is x plus 1. Now let's move on to number 1. Now always remember, every time they give you a problem that you need to factor, always check if there's a GCF first. Factor out the GCF because then you will make the problem 10 times easier, okay? So I can see that the A and the B and the C are all divisible by 6, so I can factor out a 6. Now if I factor out a 6 out of 6m to the power 2, I will be left with m to the power 2. If I factor out 6 out of 12m, I will get 2m, because 6 times 2 is 12. If I factor a 6 out of the 6, a 1 will be left. Don't forget that. It's because 6 times 1 is a 6. It's not a 0 over here or nothing. This number cannot disappear. If we have 3 terms, I should have 3 terms inside the parentheses. Okay? Now, with that said, now, do you see how A is 1? So then I need 2 numbers that would multiply to give me C and add to give me B. Very simple. Why am I not saying A, C? Because A is 1, and 1 times whatever is the number itself. So C in this case is 1. So let me replace the C with 1. I want 2 numbers that would multiply to give me 1 and add to give me B, which is 2. So multiply to give me 1 and add to give me 2. Now what multiplies to give me 1? The only thing I can think of is 1 times 1 is 1. So let's see if this works. So 1 times 1 is 1, and 1 plus 1 is 2. There you go. These are my factors. So then my first factor is going to be x, or m, since the variable over here is m. So m plus 1, and the second one is m plus 1. Now, m plus 1 and m plus 1, this is basically m plus 1 to the power 2. Now, don't forget to copy down the GCF, and that would be your final answer. Now, I would like you to take some time to try to do number 2 on your own. So please pause the video and try it on your own. Now, by looking at this problem, the first thing I need to see, is there any common factor? I don't see any common factors, so I can't take the GCF. The second thing I check is this is a trinomial. You see how it's 3 terms? So the first thing I check for is A 1 or is A different from 1? A is 1. So then this is a mental math problem. Once I figure out the numbers, I am done. I don't need to do any extra work. So I need 2 numbers that multiply to give me 5 and add to give me 6. So 2 numbers that multiply to give me 5 and add to give me 6. What are they? Now what multiplies to give me 5? 5 times 1 is 5. 5 plus 1 is 6. So there you go, I'm done. So then my 2 factors are x plus 5 and x plus 1. And that is my factored form. Now remember, if you want to check your work, you can always distribute. Now if you have an access to a calculator, you can put the standard form in y1. You can put what you got, your factored form, in y2, and then you graph it. If you get the same parabola, it means your answer is correct. If you get different parabolas, it means you didn't factor correctly. Okay? Now let's move on to number 3. Now number 3 is a little bit challenging. I wanted to add this question because I see it a lot on the SAT. So the first thing I want to see is, do you see how this factor, x plus 3, is to the power 2? And the same factor over here is x plus 3. It's the same thing. So what you do in this case is you replace the factor x plus 3 by a variable, whatever variable you want. What's your favorite letter? Let's say I want to use t. So let t equals this factor x plus 3. So I'm trying to simplify the problem and change it into something that I'm familiar with and something that I can factor. So now instead of the x plus 3, I can put a t. And now the t is being squared. Now plus 6. And instead of the x plus 3 over here, I can just put t, because I said let t replace x plus 3. So I can make it easier, and I can actually factor it faster. And I can just copy the plus 5. So do you see how I changed a complicated problem into something that I can solve? Do you see how this is very similar to the problem I did earlier? Do you see that? X squared, 6x, 6t, 5. So I wanted those 2 problems to be similar so you can see the bigger idea. So when they give you something like that and you see that the first factor is being squared and the second term has the same factor, you can just replace it by whatever letter that you want and change it into something that you are familiar with. Now you can factor this. Now, do you see how this is a trinomial and that the t-square has a coefficient of 1? So that is a factoring of trinomial where a is a 1. So you need two numbers that multiply to give you 5 and add to give you 6. So what multiplies to give you 5? You can go through the same process and add to give you 6. We figured out that the two numbers are 5 and 1. So then my two factors are t plus 5 and t plus 1, since I'm using the letter t now. Okay, there you go. I factored this problem. Now, the last step, you need to replace the t by what you assumed it is. So what did I say at the beginning? Let t be x plus 3. So once I factor it and I'm done factoring, I can now replace t by x plus 3. You see that? So now it's x plus 3 plus 5. And the second factor, I can also replace the t with an x plus 3. And then I put the plus 1. You see that? Now let's try to simplify what's inside the parentheses. So x plus 3 plus 5, I can actually add 3 and 5, and I get x plus 8. And if I add 3 and 1, I get x plus 4. So there you go. That's my factored form. So if you have something like this, and you will have something like this on the SAT, a lot of students are tempted to FOIL, write x plus 3 twice, and distribute the 6, and then combine like terms and factor whatever they get from that. Now, yes, you will get the same answer, but it's a long process, and you need to be faster on the SAT. So if you get something like this, and you see that the same factor is repeated, just replace it with a variable, whatever variable that you want, factor the new polynomial, and at the end, once you get the factored form, you can replace t by whatever you assumed it is equal to, and simplify. And that would be how you simplify or factor a problem like this.